Hey guys, so I wanted to take a quick second to do a rationalizing the denominator with cubed roots. So with cubed roots, it's going to look a little bit different than it did in the last couple videos. With cubed roots, you're going to not just be able to multiply top and bottom by the denominator, you're going to have to multiply by something to get to a perfect cube. So I have this chart, and here are all my perfect cubes. Now, we also made a chart in the 15.1 notes on the very last page, so you can also use that chart as well. This was just one that I had in my office. So here are the perfect cubes, and what this says over here is to multiply top and bottom by cube root of something to make the denominator a perfect cube. So to make the denominator on that list. And then multiply and simplify, cancel if possible. So let's look at an example. So here's my first example. The cubed root of 120 divided by the cubed root of 5. So what those steps say is I need to multiply the denominator by the cubed root of something so that when I cube it, it will be a perfect cube. So when I'm looking at that chart, I'm looking for, of these numbers, which one of those, because I multiply 5 by something to get to it. Now the smallest, because there's going to be a ton of them, so we're going to zone in on that number right there. So I made a note. I want you to think about 5 to the third is 125, or the cubed root of 125 is 5. So I need to multiply by the cubed root of something so that I can get that 125. And so I'm going to just copy this so that I'll just scoot it over. All right, I need to multiply top and bottom by the cubed root of something. So 5, because this is what I have, 5 times what number gets me to 125. So the easiest way will be to divide that. 125 divided by 5. It's going to give me 25. And so I'm going to multiply top and bottom by 25. And that's because 5 times 25 gives me that perfect cubed, 125. Now, as long as I multiplied top and bottom by something, I'm good to go. So I'm going to use the property. And the property says the cubed root of something times the cubed root of something else equals the cubed root of those two things multiplied together. Okay? So I'm going to do that here. The cubed root of 120 times 25. So I'm going to multiply those and get the cubed root of 3,000 divided by the cubed root of 5 times 25, which we said was 125. Now on the bottom, I can simplify. The cubed root of 125 is 5. That's something that you could type into your calculator. Now I need to do the cubed root of 3,000. If I were to cube root it in my calculator, I get out some big giant decimal, which tells me I need to do the factor tree. And so I'm going to work off to the side and do a factor tree of 3,000. Well, I know 120 and 25 because those are the two that I came from. And so 120 will be 12 and 10. 12 is 6 and 2, and then 6 is 3 and 2. 10 is 2 and 5. And then 25 is 5 and 5. Now remember, I'm in cubed root world. So in cubed root world, I need sets of 3 in order to make a pair. And so 125 is going to have 1 2 coming out, 1 5 coming out. 2 times 5 is going to give me 10. And then I'm left with that 3 on the inside. Now from here, just like with square roots, I can simplify that. 10 divided by 5 is 2. Let's highlight that so we can see. I'm going to simplify that. 10 divided by 5 gives me 2. And so my final answer is going to be a 2 cubed root of 3. So that would be my final answer there. Okay. Next one, cubed root of 4 divided by cubed root of 3. All right, so I've got, here's the perfect cube I'm thinking about. I looked at that chart and I said I can multiply 3 by something to get to 27. Okay, now I need to figure out what do I need to multiply? What do I need to multiply 3 by to get to 27? Well, if you don't know, you can divide. 27 divided by 3 gives me 9, or 3 times 9 is 27. So I'm going to multiply the top and bottom by the cubed root of 9. All right, so on top, I'm going to multiply 4 times 9, which is going to give me 36. So the cubed root of 36. And then on the bottom, 3 times 9, which is going to give me the cubed root of 27. So the cubed root of 27 is 3, which is good. That's why I do this in such a way to get rid of the cubed root in the bottom. The cubed root of 36, it's not a perfect cube. It's a perfect square, but this is a cube. So I'm going to need to work off to the side, and I'm just going to work up here. And so 36, I'm going to break that down into 6 and 6, and then 2 and 3, and 2 and 3. Now, I don't have any pairs, I don't have any 3s because I'm in cubed root, so I'm going to leave that as the cubed root of 36 divided by 3. And that would be my final answer. All right, last one. The cubed root of 32 divided by the cubed root of 12. So, same thing. I'm looking for something to multiply top and bottom by to get the denominator to be a perfect cube. And so I went ahead and looked at the chart, and I can multiply 12 by something to get to that perfect cube of 216. So 216 divided by 12 gives me 18. So what that means is 12 times 18 is going to give me 216. So I'm going to multiply top and bottom by 18. On the bottom, we'll do that first because it's easier. We just did that. 12 times 18 gives me 216. On the top, I'm multiplying 32 times 18, which gives me 576. Now I'm simplifying, so on the bottom the cubed root of 16 is 6 because that is what that perfect cube means. So the cubed root of 216 is 6. And then on top, the cubed root of 576 gives me this big long decimal. So I need to do my factor tree. So 576. Well, I know that 32 times 8 gives me 576. So I'm going to start there. Sorry, 32 times 18. 32 is 4 and 8. 4 is 2 and 2. 8 is 2 and 4. And then 4 is 2 and 2. 18 is 3 and 6. And 2 and 3. So I have a lot of 2s and 3s. Remember, I'm in cubed roots. I'm going to put them into groups of 3. And so I am left with 2 2's coming out of the radical. So that's 2 times 2, which is 4. And then I have a 3 and a 3 left inside, or 9. And so I've got 4 cubed root 9 divided by 6. Again, this doesn't simplify anymore. That is a perfect square, not a cube. So be very careful with those cubes. But I can reduce this 4 and 6. Because both of those divide 2, I'm going to divide top and bottom by 2 and get a final answer of 2 over 3 with that cubed root 9. And that would be my final answer.